All right, so we are in geometry. Today's date is Monday, January 13th, 2020. Make sure your name and date are on your notes. We're talking about the angle bisector theorem today. So with a quiet raised hand with your card, who wants to read the objective? Julian is fastest.
Solve problems dealing with triangles that have bisected angles.
There it is. So if I have a triangle and then I bisect its angle, and we know how to construct an angle bisection with a ruler or a straight edge and compass too. But if I actually do that, if I have a triangle ABC and I cut that triangle in half with this line right here, where this angle and this angle are the same, we're going to solve some problems. You'll see a problem down below where I actually say that this angle and this angle are the same angle. I call that angle theta. And I give you some lengths of the measures. I need to figure out that length right there. So that's the type of problem that I want to solve by the end of today. So I'm going to say if these two angles, BAD being this bottom angle, and CAD, if those two measures are equal to each other, then this is our theorem. Then if I divide this length AC by this blue length, and I set that equal to, or sorry, that proportion of whatever this divided by this, AC divided by CD, that proportion is the same proportion as AB divided by BD. So you always want to think, another way of thinking it is adjacent over the opposite. Adjacent means next to. If you don't like the word adjacent, I'll write this in another word. Adjacent is the same word as next to. So if you want to be professional, and then instead of saying my next door neighbor, you'll be my adjacent neighbor was making noise all night long and I could not sleep. So adjacent just means next to. It's more mathematical.
So can I say Gunner's adjacent to me?
Gunner is adjacent to you. Yeah, that's a proper use of the word adjacent. Question, Gunner.
I've never heard anyone say that.
But now you'll sound really educated when you say that, right?
But I don't know. What if they don't know what it means?
Then, well, I mean, that's the problem with language. You can be so sophisticated that now it's lost the meaning. And then opposite, of course. So opposite, I mean, if this is my angle, what's the farthest thing away from the angle? This is not far away. This is not far away. This length CD is the farthest away. So another way of saying opposite is farthest. So next to divided by farthest, those ratios will always be the same. And of course, I could have flipped those. If I always do farthest divided by next to or opposite divided by adjacent, that also works. That's the only theorem that we have today. I'll be proving this theorem to you at the very end of the lesson, but let's, for now, use that theorem. So I tell you that this angle and this angle are the same. I've bisected that angle, BAC. I need to figure out what this measurement is. All right, I need a quiet raised hand to help me set up this proportion. A ratio equals to a ratio. A fraction is equal to a fraction. Just do the adjacent divided by the opposite. Andres, go for it.
So we can do 3.4 line segment 3.4.
You can just say 3.4, or you can say line segment AC.
3.4 over 2.8.
Perfect. So far, so good.
What?
Yeah, so far, so good.
Is equal to 4.1 over x or something.
Over x, yeah, you can make whatever variable up you want. You can leave a question mark, you can say y, you can say heart star. That is kind of the hardest part. And you'll have to be able to remember this theorem on the quiz, on the test. All right, and then I solve with a quiet raised hand. What do I do next? Jose. Cross multiply. Go ahead and do that for us. So 3.4x, do in that direction. 3.4x, and then do the other direction. And then I think we'll need a calculator on this in this case, so I'll do it for you. 4.1 times 2.8, 11.48. This is equal to 11.48. All right, with another quiet raised hand, what do I do to solve for x? Nice and easy way to get your participation card in. Yeah, Gunner.
Divide.
By 11.48, 3.4?
No.
3.4?
Yep, 3.4.
That's right.
And again, I can pull out my fancy calculator. 11.48 divided by 3.4. And rounding to how many decimal places? Let's read our instructions again. Round to 1 decimal place. Gunnar, you got this. Round to 1 decimal place. This is 3 point.
Wait, what?
Round to 1 decimal place. 3 point.
3.7.
Is it 3.4 or 3.3?
Oh, 3.4.
3.4. There it is. So we can say now down here, x is equal to 3.4.
Oh, you sure that's correct?
Which is interesting, right? Because that's exactly what we divided by. So that means 3.4 squared should roughly be 11.48. And I'm sure that's pretty close. 3.4 to the power of 2 is 11.56. So it's off because it's...
Isn't it 3.3?
You tried 3.3.
Let's see what happens. 3.3, 10.89. No, so we're really close with 3.4 squared. Cool, and box it. Done.
Why does 3.3 go up from 3.4?
Oh, so that's a good question. Other people might have that as well. So 11.48 divided by 3 divided by 3.4. So we round up in this case because the next number after 3 is 5 or bigger. It was 7, so this number 3 got rounded up to a 4.
But like if you do 3.3 to the power 4, why is it bigger than 3.4 to the power?
So if we did 3.37 to the power of 2, that might be better. 3.37 to the power of 2, that gets closer to 11.48.
3.3 to the power 2.
That gives you to 10.89 versus
Oh, okay.
11.56.
Never mind.
All right, so I want you guys now, and you can use calculators either up on the wall if you return it, or you can use calculators on your laptop. You can just use your Spotlight search, or you can use the Desmos calculator that you have in your browser. Use some sort of calculator, set up your proportion. You can work with the neighbor if you want. Solve example 2. Good luck. All right, so going through this problem, I need a quiet raised hand to help me set up the problem. Someone that still has their participation card. Sorry for those of you that have already participated. Fernando, yeah.
So you set it up by like 5.4 over 5.1. The screen's frozen.
Oh, sorry. Yep, keep going. 5.1. Sorry, 5.4 over 5.1.
Equals x over 4.3.
X over 4.3. Perfect. Thank you. You can turn in your card. I need someone else to do the next step. Someone that has their card still. Eder. Cross multiply. Can you do that for us?
5.1x.
5.1x.
22.
0.93. All right, perfect. Everyone is good so far. 22.93. Final step. Quiet raised hand. Oh, we got a question?
I guess 23.2.
23.2. Can someone else check? Eder, you can check again. 4.3 over 5.4.
Yeah, I got 23.22.
How?
2, like all, as in all people.
Eder, can you check it one more time?
It's 23.2.
5.4 times 4.3.
I got
23.2.
So just do the cross multiply. 5.4 on the top left times 4.3.
I got
No, it's 23.2.
So these two.
Okay, that's okay.
23.2. All right. 23.2. Perfect. Thank you. Or 23.22. We'll round at the very end. Leave it as 23.22. And this is a skill that I really need to make sure you guys understand. Don't round until the very end. If you do like 5 steps and round every single step, then you're going to get a very inaccurate answer. Luckily, we only have 2 steps to do here. All right, so round at the very end. So the final step is to do what with the quiet raised hand? I'm looking for someone that has their card still. Jenny.
Divide both sides by 5.1.
5.1. Divide both sides by 5.1. And those cancel those 5.1s out. X is equal to, what did you get, Jenny? 4.1. All right. Give her a thumbs up, thumbs down.
Well, I got 4.5.
4.5.
Yeah.
All right. Thumbs up, thumbs down. 4.5. Looks like you've got it, Jenny. Thank you. All right, so go ahead and box your answer. So we're not done with the notes. Normally we would end here, but I want to talk about why this is true. In geometry, it's all about proving why am I allowed to do this? Why can I use this? That's the question. Where did that come from? So this is the part where you get to sit back and pay attention, make sure that you're not talking to your neighbors. Everyone should have their laptops closed, put their calculators away, pay full attention to this. So this is me proving the angle bisector theorem. And you can either look at your notes, you can look at your screen up at front, whatever you would like to do. So we know the only thing that we're given is the fact that these two angles are the same angle. It is an angle bisector, this line segment. We want to prove this ratio. That's the goal, right? So first what I'm going to do is I'm going to have this line, I'm going to extend it out, and then I'm going to find a parallel line to that, so I have that line that's parallel. That's how I got to this step. So now this line and this line are both parallel. I guess this is a line in the line segment, but those two are parallel. That's all I've done. And there is a way to construct a parallel line. We haven't learned that yet, but you can do that. Okay, next I'm going to say, oh look, alternate interior angles. This angle right here and this angle right here must be the same by alternate interior angles. We can all nod our heads. We know alternate interior angles, the inside parts of a Z. And also by vertical angles, this angle and this angle must be the same. We all nod our heads. That makes sense so far, Mr. Sindel. So check it out. We can tell that these two triangles, this blue triangle here and this red triangle over here, those must be similar. I'm not saying congruent. There must be similar right here because they have two of the same angles. That's true by the angle-angle theorem. You've used the angle-angle theorem before, so we know that they must be similar. Well, if they're similar triangles, then I can say this proportion, which is not quite what we're trying to prove yet. So by angle-angle theorem, we know they're proportional. So AC over CD, so this line segment over this line segment, sorry, CD, yeah. So these two are proportional to EB. So EB is this one over BD, which is close to what we're saying. We need to somehow say, hey, instead of using this line segment right here, use this one instead. That will give me my proof. So how do we get there? Well, check this one out. Triangle ABE, this triangle right here that I've outlined in bold blue, that triangle is isosceles because these two base angles are the same. Since those two base angles are the same, now I can say, well, that must mean that this line segment and this line segment are congruent. They must be the same length. That's the definition of what an isosceles triangle is. And therefore, I've converted this line segment into this line segment, and I can therefore say, yes, AC divided by CD is equal to the same proportion as AB to BD.
That makes sense.
Ta-da! The hardest part about this proof is all the way back up here and knowing how to extend this line and make a parallel angle, or sorry, a parallel line segment. Once you have that down, everything else kind of just flows out from alternate interior angles, vertical angles, and isosceles triangles. Questions, Andres?
Can I be honest?
Yeah.
Can I